Right, so let's have a look today then. We're going to look at iterative methods, two in particular. And these are ways of arriving at a root for an equation. Of the form fx equals 0. We do this by guessing x cubed minus 3x minus 4 equals 0. What do you suggest we do to try and guess that result? What could we do? We're trying to find the value of x so that x cubed minus 3x minus 4 equals 0. So what would you do, Carol? I said to you, try and find out what that value of x is. What might you do? Add 4 to both sides and try and come up with x. Well, yes, solve it's an equation. Yeah, but the trouble is it's a cubic, so it can be, it's possible to do this as a cubic, not straightforward, but could be done. But just to guess there, what might you do? Exactly, put in a value and see what you get. Give me a value to try. Two, x equals 2. Work out what x cubed minus 3x minus 4 is if x equals 2. So, how do we, notation-wise, write this down? We say the function, in this case, is x cubed minus 3x minus 4. That's the function. And if we think about this for a minute, this letter here doesn't have to be f. F doesn't say f a function. It's a letter that we use to represent that function. So I could have used a letter G, for example. And what that's saying is this function, whatever it is, with this variable x, is this. So I can put in any value I want for x in here and then work out what the function is. It's like a function machine. We've talked about this sort of thing before. Here's a box with this function in it. You put in an input, x, and out comes an output, which we'd call fx. So that idea. And so now what I can do is, and this is what you've suggested, I'm going to try the value of x. So I write f2. That means I'm now going to put the value of 2 into this function and work out the answer. So I'll possibly use brackets so that I can put this function, the number in rather, the 2, minus 3 times 2. Why has it gone blue? Oh, because I've got the magic pen up. Right. 3 times 2 minus 4. And then I work out the answer, and according to Carter, it's minus 2. So the function of 2 minus 2. Remember, we're after the value of x so that the function is 0. I put 2 in. I get a minus 2. Why 2, by the way, Carla? Was that just a wild guess, or did you? Right, okay. If I were to plot this now, here is the so up here is the function, and along here is x. Okay. So when x equals 2, the function is minus 2. So we found a point on here. When x is 2, the function is minus 2 here. Remember, we're after value of x when the function is 0. So what do we do now? What do you think? Lewis, your turn. Guess another number. 4. F4 equals 4 cubed minus 3 times 4 minus 4. So if we think about that on here, we have when x is 4, 48, way up here somewhere. That's useful. Why is that useful? Exactly. Okay, we know that our value we're after is somewhere between 2 and 4. So already we're getting close-ish to the answer. So when we use these iterative methods, we've actually gone through exactly what we do for the first step. We find values of x so that the function, one is positive, one is negative, and we know then that the root's somewhere in between. So that's our first step. So in an iterative procedure, uses this as the first step. An iterative procedure uses this as the first step. I.e., find two values of x such that the function is positive and negative. And then we know that the root is somewhere between those two values. So I'll save it.